Good afternoon, everyone. On behalf of agricultureinformation.com, I like to invite the speaker, Dr. Priya Rao, who will talk about climate smart agriculture. I now request the speaker to begin. Thank you.
Very good afternoon to all of you. I am Dr. Priya Rao, the founder director of Pelican Thermogenics Private Limited, a company based out of Kerala in India. And I have been working with organic agricultural inputs, secondary agricultural products processing, and also in the area of waste management for almost 15 to 20 years now. I'm a little excited to share something that has been very interesting for me during my journey, a topic called as climate smart agriculture. Now, let me ask you one question. I just want to begin with one small question. All of us had breakfast today morning, right? Now, the thing is, when we had a breakfast, I want to ask one more question. How many of you thought about a farmer? Not many of us would have thought about a farmer, right, while having our breakfast. But this is exactly where I want to begin this discussion about climate smart agriculture. Because every grain of rice, every vegetables, every fruit that we have, and every cup of milk, every piece of bread that reaches our table has come through some very complicated system, and that system is currently under a lot of pressure. The farmer has to deal with huge amount of variations in terms of changing weather, water scarcity, increasing cost, input costs for the farmer, energy costs, and sometimes even soil degradations. At the same time, agriculture itself contributes significantly to greenhouse gases. So agriculture is now facing a fascinating paradox, I would say. It is both a victim of climate change and also a contributor to the to climate changes. So over the next 30 minutes, I just want to take you through some very important areas that actually fall under the climate smart agriculture. What does climate smart actually mean? Now, when I'm talking to you about this word climate smart agriculture, it doesn't mean, okay, let us put a solar panel on a farm. It does not simply mean let us reduce using water. It does not mean let us reduce carbon emissions. Now, climate smart agriculture has three objectives that must happen together at the same time. The objective number one is called as productivity, sustainably increasing the agricultural output and also increasing the farmer income to meet the growing food demand. We know how much the global population by 2050 may even touch around 6 to 8 billion people in the world, and everybody needs food, and farmers also need proper incomes. Now, we cannot ask the farmers to save the planet while they themselves are struggling to survive economically, right? The objective number two is adaptation. Agriculture has to survive a lot of conditions. For example, sudden change in climate, sudden drought conditions, sometimes sudden flood conditions. There may be even heat waves that are happening. Unpredictable rainfall is also one thing that farmers may not have any clue. Traditionally, earlier the farmers could actually predict the rainfalls, and they had a season of rainfall, and then there was a monsoon, and then few weeks there would not be rain, and suddenly what happens now is there's unpredictable rainfall, and we all have been observing this, right? We have all been seeing this. That is, we'll have 1 week of very heavy rain, and suddenly, around 4 weeks later, there may not be any rain at all. So these are unpredictable things that the farmer has to start planning for. It will rain for 3 days, and suddenly there may not be rain for even 6 weeks. The third is mitigation. Mitigation is where the agriculture also needs to reduce the greenhouse gas emissions like methane, nitrous oxide, etc. So the real challenge is, can we grow more food? Can we become more resilient in terms of adaptation and also reduce the environmental impact? This is where agriculture can become genuinely climate smart. What climate smart actually means, what I told you, is productivity, adaptation, and also being sustainable in terms of growing food. More sustainability will want to increase the yield of the for the farmer and also help him to develop more income to meet the rising food demand. So it is not only one technology, it is going to be a combination of these three goals that is going to take us into the climate smart agriculture. Building resilient, helping the farmers to be able to withstand drought conditions, floods, heat waves, and erratic monsoon seasons. Cutting down on emissions, reducing the greenhouse gases that farming itself is putting into the atmosphere. Can you imagine this situation where we're talking about um, the agriculture itself contributing to greenhouse gas emissions? Look at this slide here. Agriculture sits at the center of the climate story. Why I'm telling you this point is very, very important because agriculture is not only a victim of the climate change, but it is also in one form a contributor to the climate change. Around, if you look at one third of the global greenhouse gas emissions are associated with agri food systems in the world, and around 70% of the global fresh water withdrawing is going into agricultural applications. Only 4% of the global climate finance reaches the agri food systems, with only one fraction actually going to the small farmers, the farmer groups. Let us now look at these numbers. I'm talking about one third, 70%, or 4%, only one fifth of that going to the farmers. Now, there is enormous mismatch that is happening here. The sector is very, very important for us. It is highly exposed to a lot amount of climate risk that is happening all over the world. It's also consuming enormous amount of water, but it is receiving very small amount or a fraction of the climate finances that we're talking about. Think about water. Now let us look at some practical things now. If you have a leaking tap in our own houses, what do? If we don't keep the tap running and we simply complain that the water bill is increasing. So what do? We try to fix the leak. Agriculture is having a much bigger version of these type of problems, and the consequences can be dramatic. Taking, for example, the groundwater depletion. In places where groundwater has been extracted much faster than the nature can replenish the water, the groundwater, the problem becomes much bigger. It is not simply like saying there is not enough water. It is not as simple as that. In parts of California Central Valley, excessive groundwater extraction has even created a lot of significant land subsidence that has happened. So the land itself has begun to sink down. So water is not just an agricultural problem or an issue. It is a geological issue, economic issue, and a climate issue. Let us come. I'm talking to you about six very important themes that are the core pillars, I think, for climate smart agriculture: water scarcity, carbon footprint, energy efficient farming, renewable energy usage, microwave assisted food processing, and circular agriculture. Let us not think of this as six different chapters of the climate smart agriculture. Here what I want you to look at is, think of them as six pieces of a puzzle. I'll explain this. For example, If I reduce water using in a rice field, I may also reduce the methane emissions. If I use solar energy to run the irrigation, I can reduce the diesel consumption, the fuel consumptions. If I improve the processing efficiency, I can reduce the energy consumption. If I convert agricultural waste into some useful byproducts, I can reduce the pollution and also create economic value as secondary income for the farmers. Now, one intervention can create multiple benefits. So that's the reason why I'm telling you this all the six pillars actually should come together. We are talking about climate smart agriculture. Let's start with the most basic requirement for agriculture, which is water. As I already told you earlier, 70% of the global fresh water which is being withdrawn goes into agriculture, more than what is actually needed for industry or even households. Now, let us imagine there are two farmers. The farmer A is flooding an entire field, he is owning an entire field. The farmer B delivers the water directly to the root of the plant zone. Now, which farmer is actually watering the crop? Now, both of them are watering the crops, right? But one is watering the whole field, the other is watering the plant root zone. The distinction is very important. That's the power of having a technology called drip irrigation, which became revolutionary in technologies in countries like Israel, which is a very classic example we can all talk about. A country with huge areas of desert, which got managed to develop very highly productive agricultural produce through technologies like drip irrigation and also known as precision water management. This lesson is very fascinating for all of us. We don't normally need more water, we only need to use water more intelligently. It is more about precise water management. Let us take rice, for example. Traditional rice cultivation often keeps the field continuously flooded. Now, what happens when we stop flooding continuously? We can use a technique called alternative wetting and drying process. The field is allowed to dry for a period before it starts getting irrigated again. We can save water, but we also reduce methane. Why? Because continuously flooded soil becomes oxygen, there's a reduction in the oxygen, it becomes oxygen poor. This environment encourages methane producing microorganisms. So, by changing the water management, by precise water management, we influence the microbiology and we also influence the water management and the greenhouse gas emissions happening. This is also an example of climate smart thinking. Let us look at four very important solutions. I was talking to you about water scarcity. The solution we have in place in climate smart agriculture is one, drip irrigation, as I told you. Imagining a long network of tiny tubes running through a field, instead of throwing thousands of liters of water over a huge area, water is delivered slowly near the roots of the plant. It is not only a very simple idea, but enormously very powerful when it comes to watering. Using soil moisture sensors in this area of artificial intelligence and sensors and high end technologies, we are able to make it more interesting by putting small sensors in the soil. The farmer will not have to say, I irrigated last Tuesday, so I will irrigate again today. The sensor will then start telling him, the soil is still moist. Please don't irrigate now. Or the sensor will give a trigger. The soil, the moisture content in the soil has fallen below the required threshold of, so now you need to irrigate. Now you start combining this with artificial intelligence. The system can potentially combine soil moisture content, the weather forecasts, it can understand the crop stages, it can identify the historical and data, geographical data, and recommend to the farmers how much water is to be used, when should the watering be done, where should the watering be done. That's the difference between guessing how much water and actually taking a decision based on real time data, which is involving sensors, artificial intelligence, and analysis. Right? Now, the third point is alternate wetting and drying, especially relevant to grains like rice. It saves a lot of water. It also reduces greenhouse gases like methane. And next, we have the development of drought tolerant crop varieties, which can be bred or gene edited to maintain the yield under water stress, under drought conditions. So instead of asking, how do I give this crop more water? So the next question we can ask is, can I develop a crop that needs lesser amount of water? That is where we have technologies which involve breeding technologies. The plant biotechnologies come into the picture, gene editing comes into the picture, and they become relevant. So that solution is not only a single technology, it involves a lot of other technologies. Next point is with carbon footprint. Now, if you look at the agricultural emissions actually coming from different sources, like combination of biological, chemical, and the land use processes. So these are the four major areas where the agricultural emissions actually come from: the livestock and the rice paddles, synthetic fertilizer usage, land use changes, machinery, and the indirect energy. If we look at the uncomfortable truth that we have to face here, is a farm can use water very efficiently but still can produce significant amount of greenhouse emissions. But where do these emissions come from? There are several other sources. For example, livestock, cows, and other ruminants produce methane gas through digestion. This is called as enteric fermentation. And you know, right, what we're talking about? Even cow burps are a climate problem nowadays. Yes, we have to accept that. They actually are a climate problem. A cow can produce substantial quantities of methane through the digestive process, and methane is a very powerful greenhouse gas. So rice fields, again we have methane. The flooded rice will provide environment where methane producing microorganisms will start to thrive. Fertilizers, for example, nitrogen fertilizers essential for modern agriculture, but plants don't use 100% of the fertilizers. I think almost 50% goes unused. So the unused nitrogen can be lost through the runoff, or we can talk about volatilization or even conversion into nitrous oxide, which is a greenhouse gas. So nitrous oxide is very potent greenhouse gas, and when we say use fertilizers, the climate smart question will become using sensors, using AI tools and data analysis. We have to understand how much fertilizer has to be used, where it has to be used, when it has to be used, and how precisely it has to be used. This is where climate smart agriculture comes into the picture. Cutting emissions at each source. Let us look at the solutions now. These are what was the problem. Cutting emissions at each of the sources. I told you about three major sources: the soil and land, the fertilizers and nutrients in the soil, and waste and byproducts created as a result of agriculture. Instead of conservation tillage, now instead of repeatedly disturbing the soil, we reduce the number of machinery that passes. So, which means there is a lesser amount of diesel that is being consumed, there is a lesser amount of soil that is being disturbed, there is a potentially better soil carbon which is being retained in the soil, and we can enhance agroforestry, creating more and more trees that can trap the use this carbon dioxide by leaves in the process of photosynthesis. Now, trees are integrated into agricultural systems. Now, the farm is not only producing crops, but it is also helping to store carbon, sequestering carbon. And covering crops, for example, instead of leaving the soil completely bare and open between the crop cycles, we maintain some vegetative cover. Next, we talk about precision fertilizer applications. Instead of applying exactly the same amount of fertilizer everywhere, we use AI, we use drones, we use data analysis, we use sensors to actually map the field, the whole field. And we start looking at areas or pockets where the nitrogen is actually needed. You apply it there. Then we use technologies like sensors, we have drones, we have satellite imaging technologies, and artificial intelligence can become very, very powerful. Imagine a drone that is flying over a 100-acre field, a crop. It starts to detect that one particular section is deficient in nitrogen. It detects that one section is deficient in carbon. Now, why should the farmer fertilize the whole entire field? There's no necessity, right? So, this is exactly what precision smart agriculture tries to prevent. Now we come to the next point, waste management. Crop residue and manure don't necessarily have to become waste products. They can become biogas, they can become biochar materials, which can be in addition to composting. You can convert them into valuable fertilizers, very valuable organic manures and organic fertilizers. And then we have anaerobic digestion of manure also will capture methane, which can be converted into very useful biogas, and reduced open burning of residue by converting that into biochar and avoiding simple burning. The next theme we're talking about is energy efficient farming, to understand where energy is getting wasted on a farm, or understanding the importance of energy management in a farm, which also comes under the climate smart agriculture. The most important thing when we talk about energy for a farmer, for any farmer producing organization, for any group of farmer, the most important aspect is called the cost. The cost factor is so important. Now, if you look at the diesel irrigation, which costs around 7,000 per acre for wheat and around 8,000 rupees per acre for cotton. Suppose a farmer is having 5 acres of land, almost it is like 7,000 per acre, like for example, 30,000 rupees simply only for diesel irrigation. That money isn't going to improve the farmer's household usage. It is not going for his children's education. It is not a profit for him because it comes under fuel expenses on the farm, and that is a real expense for the farmer. And the fuel prices are outside the farmer's control. We all know, right, what is happening. When the US and Iran had a war, what we observed was the erratic amount of changes that happened in the crude oil prices, which can, so any prices there is a variation globally, it starts to affect the farmer, and the farmer will start feeling the impact of this crude oil price changes. What if we start removing some of that energy cost entirely? Now, before we go into technologies for this, however, we should ask one more question. Are we using energy very efficiently in the first place? Because there is no point if you're going to use, for example, a solar system, if you want to change it completely into solar, you try to put a huge solar system panels to power an inefficient farm. Then first you need to reduce the waste also in the process. Then you start supplying the remaining energy very, very efficiently. Then we are talking about climate smart agriculture. So energy efficient farming. Now, what are the solutions here? Now we talk about the problem. Now we talk about the solutions. If someone comes and tells you your electricity bill has come to around 8,000 and 10,000 next month, let us start installing solar panels. What will be your first thought? The first thought will be, how did my bill go up to 10,000 rupees? Maybe the air conditioner is not working properly. Maybe the refrigerator is becoming old. Maybe the geyser is not working for power. The same principle also applies to farm and agriculture. Conservation or no-till farming, fewer machinery passes, lesser amount of fuel, having constant energy audits on farm operations, identifying which particular process is consuming most amount of energy. Is it pumping? Is it drying? Is it cold storage systems? Is it post harvest processing methodologies? Or which technology is using the most amount of energy? Identifying that is very important, and understanding energy audits for farm operations. Smart machinery, for example, GPS powered equipments and variable rate machinery can ensure that fuel and inputs are only used when they are required. Crop drying, this is particularly another interesting aspect where drying is also energy intensive. And we bring to a technology, for example, microwave assisted processing of technology, which also has proven to be very good in terms of dehydration and drying. Now we arrive at one of the most exciting examples from India itself. We have solar energy in agriculture. The PM Kusum is one of the world's major agricultural solar programs, and the presentation here highlights more than 10 lakh stand-alone solar pumps, a planned 50,000 crore phase 2 outlay, and more than 13 lakh grid-connected pumps solarized. You can imagine the amount of energy conservation that is happening here. The solar powering farms. A solar pump, we are not talking about some small laboratory demonstration. We are talking about a huge agricultural infrastructure, which means there is no diesel being purchased. There is less exposure to the fuel price that is being varied due to different global conditions. There is lower operating emissions and potentially a lot of significant savings for the farmer. This is where climate policy and farmer economics can actually start coming together, because the best climate technology is not the one that sounds environmentally beautiful. The best climate technology is the one in which a farmer can afford the technology, can operate the technology, can benefit from the technology, and also where the farmer's income starts increasing while reducing the environmental impact. So, adoption also must become easier for the farmer. Here's a very classic example of a renewable energy called the agrivoltaics technology. It sounds contradictory sometimes. The solar panels and the farming. Solar panels are there to reduce, and we have the agriculture all happening on the same piece of the land. You can see the picture there. Both the solar panels and agriculture, solar panels are on top, and the agriculture is happening on the same piece of the land. It is at the bottom. So usually, what will people think if they have land? They will think, okay, I will use it for solar panels. Then I will use it for agriculture. But the agrivoltaic technology person will think, why not I combine this? Why not I mix both and create the solar panels elevated above the crops, and the crops are grown underneath, that the farmer will produce the food. At the same time, the land will generate electricity, and something even more interesting is the shade from the panels can reduce the heat, stress, and water loss for some crops. The crops can also help cool the panels. So we get a two-way interaction that is happening in this combination of using solar panels and doing agriculture on the same land. So we have 1 acre of a land, for example. We have two outputs in the process. We have food that is being made through farming, farm produce is being happening, and electricity also is being generated and taken care. So we have a huge, very large agri-voltaic potential in India, and examples of potentially increased farm income from combining both agriculture and the solar revenue. This is a very, very classic example that we can think about. Another thing that we can also talk about is microwave assisted different processing techniques that are also energy efficient, that also bring about technologies which can be used for various applications in the field of agriculture. Also a technology which I have been working over the last almost 7 to 8 years. So the technology is from conventional heating to microwave heating, is that the we all use microwave at home, right? And we put food inside, and we just press a button, and within few seconds or a few minutes it starts to heat. And what is actually happening is that the in conventional heating systems, for example, we have a gas, we have a heating oven, we have a tray drying system or heating systems. The heat energy comes from outside and then travels inward. And this is about heating a potato in an oven. Just imagine this situation. The outside of the vessel will start getting heated up, and then the inside will get heated up. It is going to take a lot of time. The heat then moves towards the center, and then the heating starts. In microwave, it is completely the opposite. It starts heating inside out. It only interacts with polar molecules, and particularly, for example, water. It excites the polar molecule inside the food, inside the crop material, generating heat volumetrically throughout the product rather than conducting inward from a hot surface. That's the reason why it is very, very fast. It targets the moisture specifically, which is why it can be used for dehydration purposes and for drying purposes, and a lot of applications for microwave, shorter processing time, less heat exposure, potentially better nutrient retention, better process control, and very good operational technologies. So we talk about microwave assisted processing. I have given you some examples here in terms of crop drying, in terms of blanching, specifically used in enzyme inactivations like peroxides, polyphenol oxidases, which involved in spoilage of grains, food produce, bioactive compound extractions. We have extractions of moringa oleifera seed oil with ethanol, agro waste valorization. I'm talking to you about, when I'm using this word agro waste valorization, I'm talking about microwave assisted treatments for converting. For example, I am using making bioplastics with the waste like banana peel and plastic waste, etc. This is called as agro waste valorization. Now, when coming to this sixth theme called the circular agriculture. Now we have a loop here. We'll take a look at the loop that I have given you: crop growth, harvest and processing, residue and waste being generated in the process, waste valorization happening. That again goes as a soil or energy input in the process, which is again going and being used in the where the crops are being grown. To the core idea of this circular agriculture, which is a very important aspect of climate smart agriculture, is almost nothing from a farm produce should be a loss. Even the waste has to be utilized and produced back into the farm as biochar materials, improvising the carbon content, or as excellent fertilizers, or manure, or compost, or biogas, or whatever. There should be a conversion mechanism for waste into biochar, compost, or energy turns an air quality crisis into a resource stream. This is why it is called as a circular agriculture. So we have to look at this thought process like this. Can the waste from one process become the input for another process? So the crop is grown, we have a harvest and a process, and the residue and the waste is treated, and we have soil energy input given to the crop again. This is called the circular model. Let us think about India. We always talk about India in terms of this circular agricultural model. We generate almost enormous amount of agricultural residue which comes in the process. Sometimes the most easiest form of disposal that is happening now is simply burning these residues. We all have heard about stubble burning, right? Which is often burned, causing very severe seasonal air pollution. We all know about the NCR and Delhi areas which are being polluted through this stubble burning. And then we see a lot of seasonal air pollution that happens due to this burning. But let me ask one thing, if stubble is not waste, what if this stubble is actually a raw material? How? By you converting this into biochar material by the process of pyrolysis. Now, this can actually transform the problem when we start looking at circular agriculture as a main aspect of climate smart agriculture. So, what are the solutions? Again, we talk about the problem, we'll talk about the solution here. The circular agriculture in actual practice. Biochar. Now, stubble getting converted into biochar instead of completely being burned. This can actually improve the soil carbon being stored and the fertility, and also in the process cut down on the greenhouse gas emissions. Now, anaerobic digestion of the farm waste, for example, the manure and the organic residue can get converted into biogas through anaerobic fermentation processes, and also through nutrient rich manure or fertilizers which are highly oxygen organic content organic fertilizers which can be used in the farm. Now, water reusing and nutrient recovery, it is also very, very important aspect where we're talking about agricultural residue. Wastewater, especially from the food processing industries, does not necessarily have to become a disposal problem. We can treat that water, we can recover certain useful nutrients from that water. So we talk about nutrient recovery and water reusing in the process. Now, bio-based packaging, for example, from agricultural products, there are a huge number of applications of bio-waste from fibers, from potato peels. We have seen how bagasse can be converted into biodegradable cutlery. We can think about rice husk materials. We can think about coir fiber materials and sugarcane bagasse, corn materials, and husk and stalks from residue from farms. All these products, which are residue from the farm, which are considered to be waste, can be converted into excellent bio-based packaging products or even agricultural input products, and also converted into textile materials and fiber materials. And some of them can actually go in as animal feed residues, animal feed residues, because the fermented or processed crop residues, for example, spent grain, or we have some oil seed cakes, etc., which converted into livestock animal feed and recovering the nutritional value from the processing um, byproducts. So I'm bringing all this together into, we are connecting the dots. Now, what I've been talking to you about is climate smart agriculture. And I've been talking to you about six very important themes, which are all six parts of a puzzle. And what are the problems and what are the issues facing them? And now let's connecting all the dots. Water plus carbon footprint, alternate wetting and dyeing processing. We have one intervention which has two benefits, basically, where we are using lesser amount of water plus also reducing the greenhouse gas emission in the process. Energy efficient farming and renewable energy. So the first will reduce the amount of energy in the farm, energy wastage in the farm. Then we replace the remaining fossil energy with solar energy and renewable energy sources. So if you don't improve the energy first, and if you simply install the solar system, then what happens is there is not going to be a proper combination. So if we talk about microwave processing systems, we can talk about circular agricultural processes, and we now have moved from a concept of waste disposal into waste management and resource recovery in the process, where the waste can become a useful resource as an input for the next crop. This is the central message that I want to convey and want you to remember, that the smartest climate solutions are rarely single purpose. The most valuable solutions always solve multiple purposes or multiple issues simultaneously. Now, let us come to this situation where we have to accept the fact that although we know there are a lot of technologies available in the world, a lot of these six aspects I talked to you about, why are these technologies not enough? Because there are different barriers, and cost is one important barrier. Because if you talk about upfront cost for a farmer, like solar pumps or sensors or precision equipments, which will require a large amount of capital which small farmers will not have. And sometimes what happens is they will have some subsidy being given to them, but a part of the amount they have to give, and the part of the amount will be given through the subsidy. So imagine giving a very sophisticated AI based irrigation system, but not teaching them how to use it. So technology will become useless, right? So, infrastructure, for example, a farmer may generate solar electricity, but can the electricity be transmitted? Can the surplus electricity be sold back to the grid? Is there a cold storage system? Is there processing facilities and infrastructure? Is there a reliable supply chain management that is happening? These are real questions that we have to keep asking when we are talking about climate smart agriculture. So it is not about inventing technologies. It is not about creating new technology where a farmer, you are teaching him how to use, how to operate this, how to maintain it, and how to trust the technologies, or developing or creating infrastructure limits. It's about asking a question where can we invent or can we create a system in which the technology works economically, it is socially viable, and it is a very practical solution for the farm. So, the most important takeaways which are worth remembering is that agriculture is both a contributor to climate change and is also one of the biggest victims. So, this becomes a priority to talk about climate smart agriculture. Water and carbon are often the same problem viewed from two different angles. As I told you, alternate wetting and drying is maybe a solution to this. India is not simply sitting and watching all these activities happening around the world. We are creating climate smart agricultural solutions. We have a huge number of investors and investment going into agrivoltaics, for example. And microwave assisted technologies is not simply about making things faster, it is also about energy efficient technology and also about bringing in good quality technologies. Waste is not necessarily a waste unless you don't know how to use it. So it may be a raw material waiting for the right technology and the right economics. So what we have to understand is circular agriculture will simply ask us to extend that thinking to the whole system in agriculture. So the questions that if I ask you all to sit and solve one problem, I've given you a lot of issues that we are facing. I'm giving you a lot of problems and solutions, right, over the last 20 slides. If supposing I ask you to solve only one problem, what will you target? Will you think about water scarcity? Will you think about renewable energy? Will you think about carbon emissions? Will you think about agricultural waste? Which one will you choose? And why will you choose this particular single problem? Well, there is no single correct answer to this question, because what we are dealing with is we are dealing with varied geographical locations. Okay, I'm going to talk about water scarcity, renewable energy, carbon emissions, agricultural waste products. All this is going to be very different for Rajasthan, for Tamil Nadu, for Punjab, for Kerala, for Maharashtra, for the Northeast. It is all going to be varied. So, or even for example, another country altogether, right? So that's the reason why we are not able to give a single correct answer to that question of what will you be able to solve properly. Now we know that agriculture is hugely a very important aspect in climate change, yet only a small fraction of the climate finance is actually reaching the agri food system sector as a whole. So now who should pay for this transition? Now we want more amount of finance coming into this. Now climate smart agriculture is, we all vouch for this technologies, we all vouch for various infrastructure applications, engineering technologies, AI technologies, smarter solutions, smarter machinery and so on. But who is going to pay for this transition? Will the government pay? Will the farmer pay? Will the consumer pay for it? Will the large food companies start paying for it? Or will financial institution pay for it? Or will everybody put together pay for this transition? We all have to think about that. Agrivoltaics asks the farmers to think beyond one particular output. So the instead of saying, telling the farmer instead of saying I'm only growing crops, the farmer should start thinking I am producing food, I am growing crops, and I am also producing electricity. So that is the power of agrivoltaics. And the circular agriculture for the farmer will do the same. The farmer will tell, I produce food, I am growing crops, and I am also making valuable byproducts out of the waste. So this is the mind shift that has to happen when we come to the farmers. Now, the next question number 4 will be, if you were in a project in the state government or the government sector, where will you invest first? Will it be water infrastructure, renewable energy, or converting agricultural waste into valuable byproducts and something else? Or will you talk about enhancing processing technologies, energy efficiency, waste to energy conversion? Now, as I keep telling you from the beginning, we are talking here about joining the dots with the 6 simple pillars that we are talking about in climate smart agriculture. So, real world examples referred to in this talk here are Israel's Netafim drip irrigation system. I was telling you about. Netherlands has some excellent precision agriculture export stories. California, I told you, had a groundwater subsidence crisis. We have the PM Kusum 10 lakh plus solar pumps and 50,000 crore phase 2. We have Maharashtra's state level solar pump scheme. We have around 3,000 to 4,000 gigawatt agrivoltaic potential in India alone. We have a lot of systems where we have moringa oil extraction using microwave. We have conversions of waste like peels and converting them into bioplastic using plastic waste. We can talk about Denmark's agricultural biogas network. We can also talk about a circular economy opportunity with India's stubble burning and air quality crisis when it comes to waste valorization. Thank you very much, all of you. And I think I've given you some inputs about the important aspects about climate smart agriculture. And it's not a future scenario that we're talking about. No, it's already being done, already being funded, and it's already being farmed today in many, many places. There are scores of examples that we can talk about in climate smart agriculture. Thank you very much.
Okay. Thank you, Dr. Priya, for a very detailed presentation. Now I will take up some questions. We have another 10 minutes. Let's see how much we can cover. Okay. So the first question is just 1 second. Yeah. So the first question is, what are the most practical climate smart farming practices that small and marginal farmers can adopt with low investment?
Can you tell that once again, please? Sorry.
What are the most practical climate smart farming practices that small and marginal farmers can adopt with low investment?
Yeah, we get first we can think about, as I told you earlier, it is going to be a combination of all these things. Okay, introducing energy efficient technologies, or they can think about introducing solar panels into their system to first of all reduce the energy, especially the fuel, and then they can improvise that to dehydrate products, and also importantly try to use the conversion of agricultural waste into byproducts, which I feel can become a secondary income for the farmers apart from the crops. I think they should start investing here.
Okay. And how can farmers adopt their crop selection and planting schedules to changing rainfall patterns and rising temperatures?
Yeah, as I told you, it is again, it is geography intensive also. So based on these, uh, especially with unpredictable rainfall, and with the monsoon, which is actually erratic nowadays, we can think about drought resistant varieties. We can think about developing crops through various plant biotechnology methods, which can withstand these variations in rainfall, which can withstand variations in climatic conditions, heat waves, etc.
Okay. And which technologies can help farmers improve water use efficiency during droughts and irregular rainfall?
So as I told you earlier, right, using this technology of alternate drying and wetting can also help. And then the drip irrigation process, it's one technology which helps hugely in conserving a lot of amount of water. We have seen even hundreds of acres, in the Gulf also. In the Gulf, we all know the Gulf is actually a desert area, right? We have seen acres of land being, I have seen that personally, acres of land which are being processed where there is no water there, but they are doing it using very efficient water management techniques with drip irrigation techniques, and very little amount of water. So I think water management is a very important key aspect here.
Right. Okay. And how can climate smart agriculture reduce cultivation costs while maintaining or increasing crop yields?
Reducing the cost.
Uh, I'll repeat the question. How can climate smart agriculture reduce cultivation costs while maintaining or increasing crop yields?
Reducing the cost, well, as I told you earlier, uh, there is a system that we have in place with the farmers, the middlemen, and then it goes to the dealers, distributors, and agencies who take the money in the process. Now there is, of course, all this comes under economy with the demand and supply chain. But what I want to tell from a farmer's perspective is, unless and until he focuses on all these aspects, on being energy efficient, on reducing the fuel, reducing the energy, and reducing carbon emissions, plus utilizing and converting the waste into byproducts, it's not possible for him to actually completely bring down the cost. It is possible. It is possible to involve all these technologies to actually bring down the cost. And also, like I told you, when we are able to use technologies like microwave, for example, you create products like dehydrated beetroots or dehydrated fruits or vegetables where the storage time is very long. It can be stored for even 6 months or to 1 year, and they have the control on the cost and not the middlemen or other agencies who control the cost for them. So this way they are able to control the cost, bring down the cost, and get more money as farmers. That is one major application of different technologies which help to reduce the cost.
Okay.
I
And
hope I answered your question.
yes.
Yeah.
And what role do soil health, organic matter, and bioinputs play in making farms more resilient to climate change?
1 minute. I can just 1 minute.
Yeah.
Um,
I'll post
just
the
a moment,
question in the
Rajini. Just a moment, Rajini. I just want to 1 minute. I just want to put one message for you. 1 minute.
sure.
Yeah, I just sent a WhatsApp message to you.
Shall I post in the chat box? Shall I post the question in the chat box? Okay. Yeah. Just 1 second. Yeah. What role do soil health, organic matter, and bioinputs play in making farms more resilient to climate change?
Yes. So here, as I already have told you during the presentation, carbon sequestration is so important in climate smart agriculture. So the more amount of carbon that is available in the soil means that we are looking at a better agricultural prospect, a climate smart agriculture. Now, the organic content in a soil, the more amount of organic content that we have in the soil, the more amount of carbon will be there in the soil. So soil health, the organic matter, and the bio inputs. Now, whatever bio inputs that I'm going to feed into the soil should be in such a way that it is going to give nutrition, plus it is also going to enhance the carbon content in the soil, which is going to increase the organic matter in the soil. That's the reason why I'm keeping on insisting on the fact that we convert this organic, the agricultural residue, you can convert them into biochar, you can convert that into fertilizer, you can convert that into manure, and then put it back into the soil, in which way you are going to enhance the carbon content, therefore making this farm and the soil much more resilient to climate change.
Right. Okay. And next question. How can weather forecasting, satellite data, AI, and digital advisory services help farmers make better decisions?
Yeah, as I told you, as I already mentioned to you in the earlier slides, climate smart agriculture means climate smart technologies. Climate smart technologies means improvising on latest data analysis, latest artificial intelligence reports, using artificial intelligence, using sensors, using drones to identify the geographical location, to identify what is the moisture content, to identify what is the nutrient requirement, to understand even water content, etc., to understand the weather forecast. For example, AI, the predictive AI can predict. If you give lot of data analysis has been done by predictive AI. It can give a huge amount of data and then tell you exactly. It can predict that for this particular soil conditions, these are the particular crops which will require lesser amount of water and which will give so and so yield, will require so much of nutrition, and what is the watering period, etc. So the combination of the weather forecasting, the combination of using sensors, the combination of using drones with data analysis, predictive AI, and all these climate smart technologies have gone a long way into assisting the farmers. This is the same thing even with seafood industry. When people go into the seas, we have a lot of apps, we have a lot of data analysis tools, we have AI tools which have come up now to help the farmer understand what is happening in the farm. So we have a lot of digital data, satellite data, AI data, we have data analysis done, and a lot of forecasts which can help the farmer to take a huge amount of decisions. Like I told you, it can help him in taking decisions with respect to all the six aspects of the climate smart agriculture, in terms of the oxygen content, in terms of carbon content, in terms of the watering, in terms of energy efficiency, in terms of how to convert the waste into very useful products, and so on. So everything is going to ultimately come down to the fact that whether it is weather forecasting or satellite imaging or data or AI analysis, whatever be it, how it is going to help the farmer to make better decisions and have better management in terms of energy, water, nutrient, etc.
Okay. Which climate smart practices can help farmers reduce greenhouse gas emissions and increase carbon sequestration?
Yeah, I think I answered this already in that first question. So,
Mm.
small practices like, for example, alternate wetting and drying processes, and not using water, uh, very precision water management, where you have the water which is required for that particular root on of the plant, and not flooding the whole soil or the field. And in a process where we don't allow the microorganisms to grow, because when the microorganisms start growing, they start emitting these methane and greenhouse gas emissions. So in one way, we are able to reduce the greenhouse gas emissions by regulating the amount of water content, and also, like I told you, by very smartly understanding the carbon content present in the soil, how to increase the carbon sequestration. But one thing is, agroforestry is a huge massive example. Agroforestry is already in the process, where we have trees which can trap huge amounts of carbon. One second thing is that we can also improvise on converting agricultural waste produce into organic agricultural inputs. As I told you about biochar, or the organic, or we can talk about anaerobic fermentation process, which can get converted into biogas. We can talk about aerobic composting processes, which can result in excellent compost and manure, which can again go back to the crop. So anything that is going to enhance the organic matter is going to increase your carbon content. So these are all practices which they can employ to reduce the greenhouse gas emissions, and also to increase the carbon sequestration for trapping more amount of carbon into the soil.
What are the biggest barriers preventing Indian farmers from adopting climate smart agriculture, and how can government schemes and financial support help?
The biggest barriers preventing Indian farmers from adopting climate smart agriculture, one most important aspect is as I told you, is the cost factor. Cost is one big factor. There are a huge number of subsidies that are being given to the farmers. So when we are talking about installing solar panels or developing energy efficient technologies, everything comes with a cost. Now, what is happening is uh, big corporate agricultural giants, they will be able to utilize all these technologies and do this farming. But what happens is with a small group of farmers, farmer producers organizations, small farmer groups who are not able to actually access these technologies, cost is one factor. Now we have seen that there are some subsidies which the government is also giving, and financial support is being given. But there are some situations where like for example, they give around 70%, the farmers have to give 30%, or they give 80% subsidy and they have to give around 20%, and so on. So the cost, I think, is a very, very important barrier, and that is one thing. Second thing is that implementing and trusting technologies, that is also there, very important thing. Trusting technologies to understand how it is working, whether it is useful. So I'm developing a drone which can be used to actually assess these water content or analyze the nitrogen content, etc. The farmers, or we want to improvise on microwave technology, we want to improvise on different carbon sequestration methods. The farmers actually have a barrier in accepting new technologies. Now it is all changing, but initially, even when we have to develop an app and give it to them, the farmers were a little hesitant. So these are all small barriers. So I told you about this mind change system, right? So they have to slowly start adapting to these technologies, to energy conservation methodologies. So they have to understand that, okay, if I do this, this is going to be my result. If I put the solar, I'm going to get reduced fuel. If I'm going to put solar plus do the crops underneath, I'm going to save on the crop, I'm going to save on the diesel, plus I'm going to generate electricity. So the so if you look at solar alone, if you look at agrivoltaic systems, etc., so initial costing may be very high for them, they will not be able to invest so much. But what happens is they understand that over a certain period of time, the return of investment on this particular infrastructure is very good for me. But to understand that, they will take some time. So these are all small barriers which they have to they normally face, farmers face. Looking ahead 10 years, which technologies or farming practices do you believe will have the greatest impact on helping Indian agriculture cope with extreme heat, water scarcity, unpredictable rainfall, and emerging pests and diseases? I will again go back to understanding that there is not a single technology or a single farm practice which is going to solve the problem. Whether it is now or whether it is 10 years down the line, it is going to be a combination of technologies, like I mentioned to you earlier, about energy efficient technologies, using renewable energy resources technologies, using smart agricultural machinery like drones, sensors, AI, using water reduction technologies, understanding the importance of valorization, which is very important in using technologies for conversion of agricultural waste into valuable byproducts, which can also become a secondary income for the farmers. So I will keep on stressing on this point from the beginning of my talk, that it's not going to be a single technology, it's going to be a combination of these six pillars that I have been talking to you about.
Yeah. So now we have the last question. Based on your experience at Pelican Thermogenics Private Limited, what innovation or technologies are being developed that could contribute to climate resilient agriculture?
Yeah, in my startup company, Pelican Thermogenics, we are developing highly energy efficient microwave based heating systems that have wide range of applications in climate smart agriculture, particularly in the areas of dehydration technologies, in converting waste into value added products like fish feed, animal feed, which are already protein rich animal feed applications. We also have developed technologies. We have patented technology for dehydrating food waste, for converting dehydrating vegetables, fruits, leaves, and so on. This is a technology we are working on. We're also working on different technologies like enzyme stabilization, and also for using. We have a lot of other applications with specifically in secondary agriculture and waste management.
Okay. Okay, Dr. Priya. So I think, yeah, I think now we have come to end of question round. On behalf of agricultureinformation.com, we'd like to thank you for a very detailed presentation answering all the questions in depth. So hope this meeting will be useful for our farmers, and let's see how we proceed ahead on this. So we'll be ending this meeting now. Thank you.
Thank you very much. Thanks a lot.
Thank you. Bye-bye.